Good morning. I'm going to teach you the Knn algorithm, how it works, what is the advantages, disadvantages, how the algorithm will be framed to predict the input. First of all, Knn algorithm is the one of the simplest supervised machine learning algorithm which is used for both classification as well as the regression problems. It is also known as instance-based model, also lazy learner algorithm. For classification problems, it will find the k nearest neighbor and predict the class by the majority votes of the nearest neighbors. For regression problems, it will find the nearest k neighbors and predict the values by calculating the mean value of the nearest neighbors. KNN is a non-parametric algorithm because it won't make any assumption based upon the data. It will be finding the nearest neighbor. From that, it will be making a voting process and finalizing the output for the classification as well as the prediction. So, it won't make any new concept or algorithm for the prediction or classification. So, it is called as a non-parametric algorithm. As I said already, it is a lazy learner algorithm. Why? Because it is not creating any algorithm based upon the given data set. Based upon the given data set, it is not making any action also. If we are changing a different data set, it won't make a concept. It will making a simple concept. It will be arranging the data point with the all other values and finding the nearest neighbor. Based upon the nearest neighbor, it will be making a voting and then it will be finalizing the prediction or classification. So it is called as a instance based or memory based learning algorithm. At that instance only, with this, by seeing the neighbors only, it will be making a decision for the prediction. So it is called as a instance based learning method. So here this is the initial data we have been given. So here the stars and are representing a class A, the triangles and are representing the class B. Now we have a new data point which is having a question mark with yellow color here. Now we need to predict whether it need to go in the classification in class A or class B. So first we are calculating the nearest neighbors. So for that, from the new data point to other data point in the list, we are going to find out the distance. Next we are fixing the k value. So here k is equal to 3. For that we made a circle. In that circle we have 3 neighbors. So only the k value is 3. We will be choosing the k value as here, or many methods is also there to choose the k value, which is much important in the KNN algorithm. So now k is equal to 3 we have been chosen. So 3 neighbors are there. In that class A, 1 neighbor is available. Class B, 2 neighbors are available. So according to the voting, the class B is higher than class A. So the new data point is chosen to go to the class B for the classification. So some other example, here the red diamonds and blue diamonds are there. Now the new data point we have been given. So we have to choose which classes it need to be splitted. So we have been chosen the k value here. Total the k value is 5. Nearest neighbor 5 we have been chosen. So the k value is 5. So in that nearest neighbor, the majority voting is for blue category. So the new data point is closest to the blue squares. So it will be categorized to the same one. Like that only the Knn algorithm will work. So the steps are: the new data point we will be fixing, then we will be finding the nearest neighbors, we will be fixing the k value. Based upon that, the nearest neighbors are available in that particular k. We will be taking a majority voting. Whatever the majority voting, based upon that we will be making a final declaration of the class. So what is k in k nearest neighbor? In the k nearest neighbor algorithm, k is just a number that tells the algorithm how many nearest neighbor points or nearest neighbors to look at when it makes a decision. How to choose the k value in the KNN algorithm? The first one, the value of k in the KNN decides how many neighbors the algorithm looks at when making a decision for the prediction. So choosing the right k is much important for the good result. If the data has lot of noise and outliers, then we need to choose the larger value for the k to make the prediction more stable. But if k is too large, the model may become too simple and miss important patterns, and it may lead to the underfitting. So the k should be picked carefully based on the data. So many statistical methods are there for selecting the k value. The methods are cross validation, elbow method, and odd value of the k. Why we are choosing the odd value of k instead of the even value? With the even, if we are having a class A2, class B2, then we can't able to make a prediction. So it will become leading a tie. So if we are having a odd values, anyway in the voting output we will be having a one results comes out, so that only we are choosing the odd value of k. So in the steps I said clearly, we will be finding the nearest neighbor. How can we find out the nearest neighbor? By calculating the distance between the neighbors and the new data point. To calculate the distance in the KNN algorithm, many methods are there. First one, Euclidean distance. The formula is d of x comma y. X is the new data point, y is the nearest neighbor. Any other point we can able to choose. With the help of this formula, we will be finding the distance between these 2 points. So the formula is square root of summation of xi minus yi the whole square. Which by using this formula, we will be finding the distance value for all the neighbors nearby. Next one is Manhattan distance formula, then Minkowski distance formula, then Hamming distance formula. So different formulas are there to find out the distance. That is a different methods actually. Everyone will be leading a same result for choosing the distance value. Next, the working of KNN algorithm. So we have to select the optimal value for k. Then we need to find out the distance by using the distance metrics such as Euclidean, Manhattan, or Hamming distance, etc. Then finding the nearest neighbor. Then with the neighbors, we are going to take a voting for classification and taking the average for regression. Advantages. It is very simple because it is not making any own algorithm. Just it is going to find out the distance and finding the nearest neighbor. From that, it is going to make a voting for the finalizing the result. Then it is adaptable for any new training data. With the data set, it is easily adaptable and finding the prediction for the new training data. Few hyperparameters. Knn only requires a k value and distance metric, which is low when compared to other machine learning algorithm. Disadvantages of Knn algorithm. It doesn't scale well. Since the Knn is a lazy learning algorithm, it takes up more memory and data storage compared to other classifiers. Next, curse of dimensionality. So Knn algorithm tends to fall victim to the curse of dimensionality, which means that it doesn't perform well with high dimension data inputs. Next one is prone to overfitting due to the curse of dimensionality. The KNN is also more prone to overfitting. The sample problems for KNN algorithm. So here in the given table, they have been given the weight and height and classes for the data set. So with the help of this, we will be training the given model for the other algorithms. Here, nothing we are going to do. Just we are going to give the inputs, then whatever the new arrival, that we are going to calculate the distance. From that we are going to take a voting and then we are going to declaring the output. So now the new data point is included, which has the weight 57 kg and height 170 centimeter. Now they are asking which classes it need to go. So from the given data set, we have to predict and classify the new data point goes under which category, either normal or underweight. So the first step, we are going to calculate the distance. So we know the distance formula already. By using the Euclidean distance formula, we are going to calculate the distance. So the new data point 57 kg, that we are going to connect with weight 51, the first data set. Then we will be finding the distance. Likewise, we will be finding for our data set. So this is for height, this is for weight. So by using the formula, we have been calculated the distance for all given data points, and we have been mentioned the Euclidean distance, because two features we are having. If it is a single feature, xi minus yi. If it is a two features, x1 minus y1, then x2 minus y2 plus. Okay, so this is x1 minus y1 whole square plus x2 minus y2 the whole square. By using this concept, we have been found out the distance from new data point to all other data point in the data set. So this is the distance for all other data set. So here we have been chosen the k value as here 3. So we are going to find out the nearest 3 neighbors. So how will be finding the nearest 3 neighbors? With the help of the low value, low distance. If it is a low distance, the neighbor is very near. That is the meaning for it. So we are finding, we have been chosen the k as here 3. Due to that, we are going to find out the 3 lower values. So here we found the 3 lower values. One is 2, 3, 1.4. So very low value is 1.4, then 2, then 3. If you are looking for other values, that and all more than that. Even though if you are having a 4.1, which is not comes under the lower 3. So we have been not chosen that particular value. So the lower 3 values we have been chosen for the voting. So now the lowest 3 is already have the class. All 3 are normal. So in that chosen nearest neighbor, all are comes under the category normal. So the voting is leads the output also normal. So the new chosen point is comes under the category normal. So likewise only, what are the new points you are going to give? We will be finding the distance of the new point from other data points in the data set. Then from that, what are the k values chosen?